I'm a principal engineer at Amazon and I work on Alexa. In Gdańsk, I'm working on the Alexa language technologies. We're building foundational building blocks of the Alexa voice assistant, software for speech recognition, text-to-speech, natural language understanding, and some related services around that. I wanted to tell you a bit more about what are the interesting ways that Amazon employs when building software. And by that I mean not really the technical bits such as what languages we use or what tools specifically, but the processes around it. Some will be fairly technical, most will be pretty non-technical. If you think of what do you need to do to build software, it's very simple, right? So implement it, put it somewhere, it runs, and then it crashes and you have to do it all again. So many companies approach it this way, so that you fail and iterate and retry this until you get something that works. And Amazon it's a bit peculiar, so it implemented it to perfection, coming up with ways to do each of those stages in a very goal-oriented way. So we are going to talk about some detailed stuff like how we are building products and how we start from 6 pages of text. How are we able to get stuff done? So there is hundreds of teams or thousands of teams at Amazon that work on many products. And we have processes and tools that allow them to cooperate with each other. Because everything is done at scale, we want everything to happen automatically. So we'll also have ways to handle that. And to make it all work, Amazon is focused on one thing, metrics. And how we use metrics is basically everywhere. But there are certain places where metrics are very important to build better products. And we acknowledge that failures are going to happen. So we use that to improve. We use that to avoid failures in the future, but we also use that to build better products, which is very interesting. And I mentioned that we are a bit peculiar because all of those things come from what we call leadership principles. So those are the ways that Amazon, or the characteristics of leaders, that's why they're called leadership principles, that Amazon employs to quantify, to describe, and to measure various things. So you could use those those principles to think about a product or product design. You could use those principles to measure how well you are doing as a developer. You can use them in assessing how something fits the Amazon culture, because it's all really about culture. And the most important part of that is, well, it's not the think big, because it's the biggest here, but it's customer obsession. So Amazon wants to be the most customer-centric company, and everything we do comes from the customer, comes from making customers' lives easier, better, more interesting in some ways. And all the others are, in a way, reflections of that, or are specializations of this customer obsession in some area. So think big means that we are not only implementing cool ideas because we like those cool ideas, we are thinking how to employ those cool ideas to make very interesting products that are amazing, not just cool. Invent and simplify means that we try to build new things and then make it very simple to use. It may also mean that we are trying to reduce complexity in the designs. All of those are important in product development. And processes, we also put a huge focus on ownership, so that teams own their products, that every developer thinks that actually is empowered to make decisions for the product. Finally, one of the more important ones is insist on higher standards, which is our products should be built to the highest quality possible. So now that we have this introduction, let's go into how we design things. And by design, I don't mean just how we carry the technical design. In fact, actually, a lot of design is inception and thinking, what do we want to do? Why do we want to do it? And we don't just think about it, we write. Amazon is writing oriented, so you have to write a lot, you have to write well to be successful at Amazon. And to build a product, there is a lot of things that you have to write. We will be talking about documents that are used in design. There are also documents that we use to describe architecture. We have documents that describe our operational plans. There are documents that describe our strategy. What's important, we don't use presentation. This one is just an exception. We use text. We use something that we call a narrative. And a narrative is essentially building your vision and writing is as a story rather than a table or a PowerPoint presentation. The reason to do this is we want you to focus when reading rather than just gloss over pictures. And specifically, I mentioned that we are using 6 pages, and it's actually called a 6-pager, and there are many documents that can be a 6-pager. Why exactly 6 pages is if you measure how fast typically people are reading with attention, it takes about 20 minutes to read those 6 pages of text. This allows, in a 1-hour meeting, to have everybody read the document that you want to review, to have everybody familiarize with the contents, and to form an opinion about the document, form an opinion about what's inside, form an opinion about what you want to do, and give you valuable feedback. The typical example that is associated with building a product is peer and FAQ document. So peer means press release, FAQ means frequently asked questions. Press release is the part when we describe the product that we want to build as if it was just released and described to the press. So when we were, for example, working on releasing Polly, we had several months before written a press release for Polly saying Amazon on this day released Polly, a new service for AWS that allows its customers to synthesize speech from text. And as you might have noticed, I use plain English to describe the service rather than saying AWS will now offer a new API for TTS. And the reason is it's a narrative. It's not just context blocks of information. It's actually going to be text that people that are potentially not technical, potentially not knowing what are you building, will read and will have that opportunity to understand what you are trying to build. And we'll have questions. And when you are writing this document, you have to think about what questions the audience might have after reading the press release. And this is the frequently asked question. So you imagine what the questions might be and provide answers. Provide answers as to what's the purpose of the product, provide answers as to how it's going to work in detail. And we provide answers both for external customers as well as internal teams that are helping or reviewing those documents. So this gets pretty detailed, so you could have questions that range into things like monetization or architecture, and actually typical documents will also include some very short description of the solution, which is either the architecture or some other, for example, graphical design or things like that. And as you have seen, we were going from press release and started with press release. We call this working backwards. So this is a pretty Amazon-specific term, and it doesn't mean that we are actually working backwards, but we start from the customer. So we try to put ourselves in customer's shoes and understand what the problem is for the customer, we try to understand how to solve this problem. So whether the problem is solvable at all, if it's worth solving. So there may be some cool ideas that we have, and after trying to go through this process, we determine that, okay, but this is a problem that we don't know how to solve efficiently. So maybe we'll need to wait, or maybe we'll find a different way, or maybe we'll find a slightly different approach to the problem. And when we do propose a solution, or we do propose a product that solves the problem, we also identify ways to measure if the product is successful, and those are success metrics. So right when we are designing the product concepts, we haven't yet started to build it, we already will know what we will use to measure if it's successful. And success could be something very trivial, like how much money will it make if you are selling something. But it's not the only metrics that we are interested in, and we'll go into that in detail in later chapters. We have to identify many more metrics right at the design stage. When we are done with this product concept, comes time for technical design. And technical design at Amazon is also, it's not as rigid or formulated as strictly as you have to write a 6-pager document, though still you would want to have documents rather than just pictures or diagrams. There are some certain principles that we expect people and we expect teams to follow in design, and the chief one is be flexible, and all of the ones that are here on the slide reflect that. So you have to think about what will potentially change in your product after you build it. One of the things is avoiding one-way doors. This is, again, Amazon-specific concept, but it describes decisions that cannot be easily undone. And when you think about where it may be applicable, many of our products are, for example, AWS APIs. And as AWS states on many occasions, APIs are forever. So once you release something as an API, you better be sure that you are doing it the right way, because you will have to support this API probably forever. And this reinforces the thinking that, okay, so if we are building a feature, should it really work this way? Or should this feature or this API be built in a way that will allow us to then change something? So that's enabling innovation also. So building products in a way that we can improve them rather than build a sealed box that you cannot really do much to. And Alexa is a very good example of how it was designed. Is everything is in the cloud, but we have a tiny speaker, right? So the architecture reflected that by putting all of the features in the cloud where we can easily modify it, while the most restricted component of the system is something that we cannot modify. Other things are very similar to what you get in other places, I guess. So we try to release early and often. So you'll see Amazon releasing its products in beta to limited amount of customers to get valuable feedback. We value performance, reliability, and security, and you have to think about those at the design stage. So we have to think about how our product will perform, how it will work well, and built in security from the get-go. And we'll talk about security in a while as well. Finally, Amazon is a global company, so we try to build our products so that they are global and accessible. Now, it doesn't mean that Alexa will be working in Poland anytime soon, but the architecture and the design for the system means that it is possible, so that we can, at any time, introduce new languages. We can introduce new ways to communicate with the system and make it easy to communicate. For example, if you're disabled or if you only interact with the computer in a very limited channels, which is particularly important for Alexa, again, where we have different communication channels depending on the device, and we never can assume whether the customer will have a screen, what kind of voice input will he have, and what kind of speakers, where those speakers will be, and so on. So all of those things mean that we have to be very careful when designing our experiences so they are accessible to customers. Okay, so if we designed everything correctly, it comes time for build part. So and we'll talk mostly about implementation, but really about things that we use to make implementation efficient. And the key concept that we have to put in mind when we are building things at Amazon is we're building services. So it might be seeming from the outside that what Amazon is actually doing is, well, we are selling books, we are selling devices, we are selling many things on the marketplace. We now do pretty much everything. We also have AWS, which does provide APIs, but underneath all of that is very service-oriented. So Amazon underwent transition to the service-oriented model long time ago, right when it was moving online, being converted from just a bookstore to more than that. And ever since, this principle allowed it to keep evolving very fast. Because we are not building frameworks, gigantic pieces of software. We are not building components that need to interact with each other. We're building API interfaces. If you think about your product being a service, then you are much more flexible and you are much more reliable on its own, and you are much more independent from other services because you really need to care about your service working well. Because you are independent, if we go down into details and the tools that we have, all of those services are essentially hosted and developed in separate Git repositories. The fact that they are separate doesn't mean that they are unrelated. So we have build systems. Internally, it's called Brazil. Externally, you might know it as code build. And those systems allow us to integrate software from multiple of those repositories, knows about dependencies between different components and services, and are able to build software automatically following all the dependencies. So again, you focus on your own component, on your direct dependencies. The system thinks about everything that happens outside, and this will get pretty complex, as I will show you in a minute. Finally, when you do build something, we have versioning and deployment systems. And again, internally, we are using a system called Apollo, which has been released, form of it has been released as Code Deploy, which is essentially a packaging system that can deploy things into virtual hosts. And this allows to build packages. It allows to build binaries. It allows to build libraries. So it's pretty flexible in what we are building. But most important part of it, it's using a pretty interesting versioning scheme. So because we are treating everything independently, we don't have a shared master branch for all Amazon software. We don't have a shared release branch that we could say that this is the release branch for my project because it might have dependencies. So what we have instead is version sets. And those version sets have versions. So the picture shows hypothetical components, foo and bar, which are developed independently. And foo may depend on packages ABC and XYZ, and bar may also depend on packages XYZ and ABC, but they are all developed and built against different versions of those packages. And coming back to this independence that I've talked about before, this is what you get if you are completely independent. So what happens if I am foo bar and I need both those two components in my build? Well, our build system will be able to figure out that because ABC changed only the minor version, the owner of ABC needs to be aware that if he's only changing minor version, it should retain backwards compatibility. Okay, so we can take ABC version 1.4. For XYZ, we have two different major versions, and now the contract again states that, well, they can break compatibility between versions, but those libraries or binaries should be independent of each other. So now it's a completely new interface. So we can link to both XYZ and XYZ from our new product, allowing the foo and bar components to work together. And this happens automatically, so that's the best part of it. So you don't really need to worry about it until things get too complicated, in which case you will have to perhaps manually choose which version you want to use. So if you really wanted to use ABC in version 1.3, you would be able to do so, perhaps with some unintended consequences. So all of that is managed by things that we call version sets. So version set for release for foo includes those component versions. Version set for bar includes those component versions. And what we created by releasing foobar 1.0 is a new version set, which also tags the versions of those individual components. So when somebody wants to consume foobar, it will know that our dependencies are those packages in those versions, and so on and so on. And this allows us, again, to retain independence and create independent services, and in turn, several steps above, create the building blocks or primitives for our infrastructure. And again, we use those primitives to build other pieces of our products. So internally, for cloud features development, because we are using services, well, we are building them on top of other services. Our software runs on EC2. We store files on S3, and we use Elasticsearch, DynamoDB, RDS to manage our data. We use CloudFront for hosting, and we use internally between services, we use SNS for sending notifications. All of those are built inside Amazon using the shared infrastructure, and on top of those shared infrastructure. So DynamoDB underneath it uses S3 to host its files, and so on. And having this library of primitives, similar to how external companies can use the AWS infrastructure externally, and focusing on this, we are able to prototype and build infrastructure much easier because we have all of that in common. Okay, so what it gets us if we have those independent teams? Well, we can really have a form of agile development. So we are not a startup, obviously, but each team can be. So they can work like a single startup. So if you are a team at Amazon and you don't really have much external dependencies, you are building infrastructure, building your software on top of AWS Cloud. So there is very little difference in functionally in how you can go on building your product. We try to limit teams to rather small sizes. So we call it 2 pizza teams. And 2 pizzas is, well, how many pizzas you need to feed your team. Depending on how many pizzas you have per developer, this means between 4 and 8 people is like ideal team size. And this team size should be a single-threaded owner or something. And single-threaded ownership is again, Amazon-specific concept, which means that this team should be focused on one component only, and not one component, one product or project or service. It could have internally multiple components, and should have ownership of that component. So if I'm the manager that's leading this team, I should be able to set my own goals, I'm owning the development of the product. Of course, product development doesn't happen in vacuum. So, well, you are building your product for your customers. Those customers could be external, could be internal. So you as the owner, if you are doing your job well, need to reflect the needs of your customers in your development, but you are owning and making decisions. So that's very, very important. And it allows people to actually feel involved and motivated to focused on their project because they are owners. This also allows them to employ various processes much to their liking. So we are using some form of weekly or bi-weekly or monthly sprints, and this is up to the team to decide because they do it the way that they please. We have various release cycles, so we have some teams that have monthly cycles. We have some teams that deploy every 5 minutes, and this is also something that our infrastructure that we have allows. And depending on your product and your needs, you may want to have one or another. So some of our infrastructure in AWS is following very rapid development cycles. We have some components where we are training machine learning models, which takes a lot of time. So we have slower slower release cycle, but still we can use similar approach to the rest of Amazon. There are two principles that we try to hold on to regardless of the place. So one is testability. So there is huge focus on making the components testable, and we'll get to how we do it in the next part. And we always require code reviews. So each change that comes out and gets integrated into the repository has to be code reviewed by somebody. So it typically is somebody from the team that owns the code. Sometimes when I'm a developer and I want to fix something in somebody else's project, I might want to do that, but I have to get a code review and approval from that team to actually do this. But this applies also when I'm doing the same internally. So we enforce that people are always reviewing this. So all the code gets reviewed before getting committed. Once it gets committed, so we can build something, we are preparing for deployment. So how do we actually run it on this massive infrastructure that Amazon owns? So because when you are building a product, you probably are not trying to run it just on a single server, which would make it much easier. You are trying to build something that will work for millions of customers and handle pretty high levels of traffic. So we have support for automation of all of that. And this tool is called Pipelines. And externally, a very similar tool, which is called Code Pipelines. And by the way, I'm saying internally, externally. Externally means AWS, so stuff that anybody outside Amazon can use, but it doesn't mean that we cannot use it internally. So some teams are using the internal version of Pipelines, some teams are using the external version of, which is AWS Code Pipelines. It really depends on the preference of a team, and probably will get more and more focused on the AWS versions over time. But in purpose, they are similar. So what Pipelines allows you to do is to hook up some product deployment steps together and execute them automatically or semi-automatically, which is also important. And those phases could be compilation, running integration tests, then automated deployment on some staging machine where you can do automated health checks and see whether it is actually still running and works as it should. And finally, it would go into full production deployment where we would also stage this. So first you would go to beta, then it would go to the full deployment in some stages. So we first update one host, then 5, and so on. So this staggered deployment is also a feature of both the Pipelines and Apollo underneath, so that we can control deployment at every single stage. Even if we are updating thousands of servers, we definitely don't want to just kill all of them at once and update. We want to do this slowly so that we can roll back efficiently. And rolling back is also a feature of this process, so that we can stop everything and quickly go back to the previous version if something fails. Finally, after a pipeline completes, it can connect to other pipelines. And when I was talking about version sets before, one of the primary features for pipelines is building version sets. So when I integrate a new change, it goes through a pipeline and a new version of a package gets created, and the version set is updated. Another pipeline somewhere else can connect to my pipeline and build their own package that incorporates changes from my version set. One of those pipelines could be something that pushes the code to production. So all of this is automated and flows through the system somewhat magically in some regard. If something fails, I get an email, or I get an alert, or I get a page, or my boss gets a page, and depending on what fails. And to prevent those failures, we also have semi-automated deployment, so you can have an approval step. So not everything flows automatically. We have a step where somebody has to review whether, okay, should we push this forward? And this is how you control the release process and how you can have weekly or bi-weekly, or so you can put an either automatic or half automatic or approved steps of the process. Okay, so everything is pushed automatically, and when it will be running, it will also be scaled automatically. So we do monitoring everywhere, and again, I will talk about monitoring a bit later. And we do monitoring at several levels. So both the virtual hardware is monitored at the service level, and it's monitored. The traffic that flows is also monitored. So we use automatic load balancing, either hardware or software load balancers, so that we can efficiently scale distributed traffic among multiple instances of the service. And capacity scaling, so ECS support this out of the box, so that when our load gets beyond some configured threshold, it will automatically scale up. And what's important is all of that, it's also part of owning the service. So it's the team that builds the service that has to deal with those operational aspects as well. So we don't have operations teams. Typically, we don't have operations teams that are focused just on this. We have developers who are also operations, so DevOps, and they build those processes. They have a huge incentive to build those processes because everything will happen automatically. And they own those processes and monitor them. So have to make sure that everything runs smoothly and also securely. So before we actually are able to go push our service to deployment, we have to make sure it's a bit of a design, it's a bit of implementation, but where it finally matters is being ready to deploy. So we have something called operational readiness, and it includes the automation that I mentioned, scalability that we've talked about, and also security. So we require all our services to authenticate to each other. That's one part. So if I'm building a service, I cannot allow everybody to call any APIs just because they like it. I have to know that the service that's calling my API is actually authorized. In AWS, it's also happening out of the box. So we have the AWS user needs to be authenticated, and the identities are managed by IAM, and policies are managed somewhere. So all of that is also managed by shared infrastructure. But you have to think about it when deploying your service. Everything needs to be encrypted similarly, so everything in traffic is encrypted, secure from somebody that would try to snoop at it somehow. And when you store the data to disk, you typically want to encrypt it as well. So when we get some bit of data from the customer, when we store it to S3, we encrypt it with a key which is held separately from the data, which again means that it's far less likely that somebody will be able to just grab this data by, I don't know, stealing a server from a data center. To guide us in how we manage this data, we have data classification processes. So when going through operational readiness, you have to think of what different types of data you are processing and follow the guidelines to find out what types of processes they have to go through. So if it's, I don't know, a bit of a review that a customer put on a product somewhere, it's public data, and typically you don't really need to worry that much about the way that it's handled because, well, it's public, right? There is no problem if it gets published because it was already published. If it's your home address, then probably it's very, very secure, and you have to encrypt it. You have to make sure that it doesn't get unnecessarily distributed. If it's your credit card address, then it goes even beyond the credit card number. It goes beyond that. So we actually only have one service at Amazon that is allowed to process credit card numbers. So you just can't do that on your own. So it's very controlled. And all of that is part of a process we have for when we want to deploy services for the first time and also following any changes, which is security reviews. Both data and what are the threats to the system. So threat modeling, figuring out how people can harm your service, and those could be malicious attackers that know exactly what they are doing. Those could be denial of service type attacks when people are just trying to hammer the service as hard as they can. All of that is covered during a security review, and we have security engineers that both help you identify those threats and help prevent them. So they will suggest ways to solve problems if they find any. Okay, so now our service is secure. It's fully automated. So we run it. Okay, so finally it's launched there. Okay, ready, but not really ready. When we were talking about the design process and 6-pagers, I said that there are metrics that we define at design stage, and Amazon is a metrics-driven culture. So because we have the metrics already, and those were built into the service, so we now have a source of those metrics. Now we will start reviewing them. So every service has either weekly or bi-weekly or monthly, and again, depends on the service, operational excellence meetings, at which the service metrics are reviewed. And operational excellence means whether our service is performing as good as it can. So we'll get into the details of that, but we'll look at various metrics that are generated by the service on a technical level and figure out whether everything is healthy. We'll look at the reports from crashes or failures or customer provided feedbacks and figure out whether there aren't any problems that we have missed in all those metrics. We'll finally look at business metrics. So the product also defined not just technical but business criteria, whether our product is successful. So we'll review those as well to see whether, okay, so everything works fine but nobody is really using it. That's bad as well. So all of that are things that are reviewed regularly when we have a service already running. If some of those things require improvement, we try to improve. And we get this data from monitoring. So all of the systems internally, we have an AWS service called CloudWatch, so it's this is pretty similar. Internally, there is an automated metric collection system, which also allows to collect data from all the systems that are running in Amazon. The teams are expected to build and own alerts and pagers for important violations of those metrics. So if some given metric goes above some certain threshold, automatically a pager rings somewhere, so somebody is perhaps woken up, perhaps just brought to attention to make sure that everything can be fixed as soon as possible. Developers will have dashboards and runbooks which allow them to quickly view if the service is running correctly. And the runbooks tell developers what to do if something's wrong. So we collect data in those runbooks, stories or procedures for how to deal with errors. And we'll get how that happens later. And finally, all of the metrics are aggregated in a central system so that even if we don't have a dashboard, we can also always dig in and look for a metric. So we can look for any particular bit of data. If something broke, we can try to diagnose it even if we haven't thought about it could break before. I wanted to get back to how we measure the operational excellence at from the previous slide. So I said that when a service exceeds some level, service metrics will exceed some level, we'll go into alert mode. So each service defines its own SLA, service level agreements. Either it defines it for itself or for its customers. The purpose anyway is setting expected reliability, latency, performance goals. Latency is probably mostly important for the customers, reliability for everybody, performance is important for the owners because we want the service to be as efficient as possible. And we defined various levels at which those numbers are measured. So you might hear sometimes cryptic terms like P50, P90, P99. Those terms mean percentages, and specifically P50 is that 50% of the queries should be under some given level. P90 is 90% of the queries should be under a given level. And the typical level at which we actually look at problems is P99. So we don't build our metrics to just look at P50 and say, okay, 50% queries are under 100 milliseconds. Oh, work done. Okay, we don't have to worry about anything. No, we look at the 99th percentile and see how badly the things go there. Or if we are Amazon Web Storefront, so the page that millions of people use every hour, we look at P99.9999. 5 nines. So we look for problems there, because if problems start happening there, they can later develop in problems that can affect bigger and bigger portion of the population. And that's why we define metrics even for those very, 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 very small numbers or very big numbers, depending on how we look at it. And if something goes wrong, we automatically get an alert, and we try to fix it. We'll get out how to fix it, but we also drive to improve those numbers. So once we start and we run, we see that there are some trends. Some numbers are too bigger than we wanted them to be. Even if they are lower than error thresholds, they may be getting close. So the service owners are expected to drive to improve those numbers, so to keep them in check and improve over time. If this is latency, well, every customer will want their pages to load faster, right? So we want to improve those metrics. If something breaks, well, we need to have an alert, and we have a failure. So something broke. Now, when something fails, and something will inevitably fail, obviously you want to fix it, but Amazon goes slightly further in terms of what we do to fix an error. And this is correction of error process, and known as COE. It's described variously either as something between a post-mortem or 5 whys, or you could hear different descriptions of the similar processes. But the underlying purpose is to find the root cause of the error, then fix underlying issues, then prevent similar issues. So we don't just stop at, okay, there was a bug here in this line of code and it caused us to, no, you have to ask for it. Okay, so, but why wasn't it caught during automated testing? So you have to fix test. Okay, but if we had it tested, so why wasn't it covered? So maybe we haven't thought about errors like that, and we should have added something to the operational guide. Why wasn't it caught even if it was in an operational guide? Or maybe our infrastructure had an issue. So you have to dig deeper and deeper, and as you go, you incorporate findings to various documents that describe how to deal with errors. You just incorporate this into the guides for operational readiness. And finally, you might also come with conclusions that you might want to do something else entirely, like build a new version of the service. Either way, the team that owns the service owns the improvement process, which may span several teams. The corrections of errors are handled at organizational level. So if you fail, other people in the organization will also be able to benefit from the discovery process. And as you might have guessed, the correction of error is also a document, also a 6-pager in some cases. And it's a story that involves the timeline of the error, it involves the root causes of the error, it involves how the story was investigated, and it incorporated findings or goals or measures that can be taken to prevent some things like that in the future. And failure, failure is something that will always happen. So one of the guiding principles of the designs that we have here is if anything can fail, it will fail. So we build our service for failure, and this means several things. So one is fault tolerance. So if something else fails, you should be able to survive without it, unless you can't really. If you really depend on something, but could perhaps fulfill some portion of your service APIs without that, you should just focus on that and make at least that part work. It's called graceful degradation. If a part of your service fails, you should always be sure that the rest of your service still works. That's high availability. So, and there are several ways to achieve that. So one is replication, but it's not just that. So you could have replication, but still have a high impact customer that kills every instance of your service. So you want also to be resistant to that. So you might want to isolate your customers if they are misbehaving, or isolate them by design, so that a customer cannot affect more than one instance, or cannot affect more than several instances, but not all instances. Finally, if it's not just one customer or one source of problem, you have to be scalable. So if things are not an error or not a malicious problem, then you have to grow. So, and we go back to this automatic capacity handling, automating efficiency. You have to be scalable in many ways, so that you can handle customer growth, capacity growth, storage growth, and so on. So all of those things can grow. You have to think about it. Well, but you know, if anything can fail, it will. So you have to keep it in mind. Okay, and that's it. We're now building the next version of the service. So any questions from the audience?
Thank you, Staszek. Anyone? Questions? Staszek answered all his questions before they have been asked.
Maybe. There's somebody there.
Yeah.
You have mentioned that your teams focus on I would call it vertical solution, which is whole service. And what about underlying components? Are some owners of those components who have a long-term vision, or it's also it's owned by all those teams which are doing services?
There are certain cases where we have a component which is a part of another service. It's pretty rare. So there are certain teams that build infrastructure components, like, I don't know, web framework or protocol for authentication. So those are typical cases where you have a component which is part of several other services. In those cases, those are internal teams, really, which are for which the customers are other developers. So they have slightly different way that they operate, but they still can be seen as owners of those components. And the versioning system that we have still allows them to be independent. So even if they build the next version of their component, they still will maintain the old one. So they don't have a way to isolate themselves behind the service, which makes their work harder. So they will want to isolate themselves through hardened APIs or independent environment deployment. So what we do in those cases, one of the solutions that we do in those cases is we have team A that's building authentication service and team B that's doing regular web service. So team A builds a tiny library component which communicates with a local service which they own. So now what they are building is a service that is deployed along your service onto the same host, and a tiny linking component which works like all the other components. The only difference is they talk to a service that's running on the same host rather than a service that's running somewhere else. This allows this separation to be very similar to how we are building services, while at the same time doing this dependency, stricter dependency modeling than when we have cloud components.
Thank you. Okay, one more.
Hi, one question. How do you approach the problem of
cost efficiency of the services you are developing. Let's say it's easy to build a reliable and scalable software, but it's not easy to build a cost-efficient, reliable, and scalable software. So do you monitor cost per service, per team, per product?
Reliability always comes first, and we do monitor costs. So if you are spending unnecessarily, you should look for ways to improve. And if you can justify that, to make your service work reliably, you have to really spend this and this amount of money per customer or per query. Well, then there's that. So that's the cost of running the service. So you are the owner. You define what's the cost of running your service reliably. If we do not sacrifice on reliability, I'm not aware of that. So there haven't been any design reviews where people would say that, okay, so doing this in a reliable way would be too expensive, right? So maybe some edge cases where you could offer some bigger feature set or smaller feature set, and those. But then it becomes a product decision, right? So you want to be support all of those features. So I guess, yeah, it's always comes down to looking from the customer side, what the customer really wants. And if the service is going to be more expensive, well, then it will be more expensive. It may turn out that it may be too expensive for the customer to actually want to buy it, right? In which case, we probably will not be able to have an effective business model. Those things happen as well, right? So, but we never compromise reliability.
Any other questions? Oh, that would be tough. Oh, we have here.
You have mentioned that you're using some internally some versions of the publicly accessible services like the Brazil and the Codeploy, if I remember well. I wonder what's the relation between the internal and external services. Do they share the same code base? Do they have the internal versions have more features?
In some cases, they share some of the code components. Or were built from the internal version to the external version. The key difference is AWS uses a different security and ownership model than the previous Amazon infrastructure used to. So we didn't have a concept of AWS user as the intermediary between the customer and Amazon infrastructure. So this concept was slightly different. So we had every user was an Amazon user, and the various teams had their own identities. So the difference is mostly in this identity management, and because of that, those services can be built different. Also, AWS services are newer, so they are typically more adapted to cloud development and pure cloud-driven development. Some of the services in Amazon are still supporting some legacy components that were built before even AWS existed. So those systems are different, related in functionality, and it's reasonably easy to migrate from one to another. It's probably not very easy to just, it's not automated, so you cannot say that, okay, I have my system configured in our internal build system, now I just want to transfer it over to code build. So it doesn't work as plainly as that, although there are teams that are working on something to make this process easier. And I guess over time, Amazon tries to focus on a single solution. So AWS solutions are encouraged for all teams to use, so that over time we probably will use more and more of that.
Okay, thank you very much. Thank you for your questions. We are cutting. We need to cut short to keep the agenda. Thank you very much. Thank you very much for your questions. And Staszek will be around to answer your questions.
Yes.
Thank you.